you want to join the space industry, but you have a mechanical engineering background, or maybe you're sure that you want to work on spacecraft but you're confused whether to go for a mechanical or aerospace engineering degree. Well, I got you covered. But first, don't forget to subscribe and click on the bell icon so you never miss a single upload. So first things first, who am I and what gives me the authority to give you all this information? I hold a bachelor's degree in mechanical engineering from the University of Twente, and I later continued on to do an aerospace engineering degree at the top school for aerospace engineering in Europe. I chose to specialize in structures for space in my master's, and that's literally the closest thing you can get to mechanical engineering while designing spacecraft. Now in this video, I'll walk you through the role of mechanical engineers in a space mission through different phases, from launch to orbit. But before I get to that, let me talk about the difference between an aerospace engineer and a mechanical engineer in the context of the space industry. Now, from a university perspective, one might say that mechanical engineering is more broad and aerospace engineering is more specialized, because aerospace engineering focuses more on air and spacecraft, while mechanical engineering is, simply put, the study of machinery and focuses on a broader perspective. But when it comes to the space industry, in the context of building a spacecraft, the focus of an aerospace engineer is a lot more broad, taking a look at the design of a spacecraft through a big picture perspective, putting all the different subsystems together, the role of an aerospace systems engineer, or maybe focusing on things such as propulsion or mission planning and analysis, make sure that the spacecraft follows the right trajectory and orbits it needs to, that a mechanical engineer would not necessarily see. Meanwhile, a mechanical engineer focuses more on specific subsystems within a spacecraft. So now, before a spacecraft goes into orbit, you need to send it up there in the first place. Every space mission begins with the launch. Now, this is where I believe is the heart of spacecraft mechanical engineering. Structures, which is essentially the physical framework, the backbone, the skeleton of spacecraft and launch vehicles that support all the other subsystems physically, which means that they need to be lightweight, strong, and stable. So structural design and analysis engineers are the kind of mechanical engineers to ensure that spacecraft do not break. Now, the environment that a spacecraft or a space system goes through is so demanding, whether through launch vibrations or in the extreme heat and cold of outer space, are extensively tested through vibration tests on shakers, vacuum chambers, and thermal cycling tests. And a rocket launch is perhaps the most mechanically demanding environment that an average spacecraft will go through in its entire life cycle. So we know how powerful and violent a space launch can be, and the vibrations alone from the noise of a launch can be enough to damage the rocket itself and the spacecraft within it. So a structures engineer is the kind of mechanical engineer that makes sure that the things they send into space are not only lightweight, but strong enough to withstand all the demanding environments, all the vibrations it'll see during launch, or other launch events such as the shock loads coming from booster separation or stage separation. Now, let's say your spacecraft has been successfully placed into orbit by your launch vehicle, but it's not in its final configuration yet, because spacecraft are often packed in order to fit the following requirements of a launch vehicle. So before it can begin its mission, it still needs to do a couple of things like deploy the solar panels or instruments within it. And mechanical engineers can design the mechanisms for unfolding these solar panels, or figuring out the deployment configurations, or even the best way to pack a spacecraft within the launch vehicle through origami structures, for example, and how do you unfold these structures into the configuration your spacecraft needs to be. And once you're in orbit, your spacecraft must deal with some microvibrations coming from, for example, moving reaction wheels when changing its orientation. But the biggest thing to worry about once you're in orbit is temperature, because space is really cold and really hot at the same time. It takes a spacecraft approximately an hour and a half to orbit the Earth, and half that time it would be in the sunlit day side of orbit, where temperatures can reach above 100 degrees Celsius, and in the other half, your spacecraft faces the absolute zero of space. And this is where you deal with thermoelastics. When things heat up, they expand, and if they cool down, they shrink. So this can be a problem not only for the spacecraft itself, but for the payload. So if you're a mechanical engineer responsible for the payload, you want to make sure that the bench that the instrument is resting on does not get too badly affected by thermoelastics, because pointing accuracy and stability is obviously everything when it comes to measurement systems. So essentially, structures and thermal are interrelated, and you can't have one without the other. So if you're a mechanical engineer in space, you might be a thermal engineer, where you make sure your spacecraft doesn't get too hot or too cold, where you design systems for thermal management. And if your spacecraft is coming back as a thermal engineer, you might be responsible for the heat shield or the thermal protection system of a spacecraft to protect it from the extreme heat of atmospheric entry, as your spacecraft travels at 25 times the speed of sound and converts a lot of the kinetic energy into heat. So bottom line here is, mechanical engineers are more than needed in the space industry. Mechanical engineers are the most responsible for these three things: structures, the physical backbone and framework of spacecraft and space systems; the thermal subsystem, where you deal with thermal management of spacecraft in orbit or planetary entry; and mechanisms. And if you learned a thing or two in this video, please leave a like, comment, subscribe to this channel, and I'll see you in my next video.